Hello everybody. This video is to help you get started on this robot vector project that we're doing for section 7.1 in pre-calculus. So your goal here is to try to guide your robot in these shaded areas past certain obstacles so he does not get destroyed. So in this first one, for example, we want to take our robot here, and feel free if you want to give him a name. What's the name of your robot going to be? Think of something cool and creative. His goal is to get from this starting dot here all the way over to the end. But obviously he can't get there directly, otherwise he would perish in this wall of flames, and that would be bad. We like our robot. So we have to find a way to get him to the other dot without going through the fire. So you see, first of all, that they gave you a sort of guidance dot over here. So what I would do is, can you try to draw a vector that goes from your starting dot and goes all the way to that guidance dot? Notice that we're staying in the shaded area. We can't go outside the shaded regions. And once we get there, then can you come up with another vector that goes from that dot back to where we need to go? Now, in order to do that, what you have to think about is just counting boxes. How many boxes does it take up, down, left, or right to get from the beginning to the middle, and then from the middle to the end? So let's count. Let's start, for example, on this opening dot. Let's see how far it takes. So let's draw my vector first. I'm going from my start. I'm going to draw my vector all the way to that dot. There's my vector there. Okay. Now, if this was an XY coordinate plane, we could think of actually where the dots are, but we don't really have to think that way. We just need to think about how far did you move horizontally and how far did you move vertically. So, for example, to get to this starting dot to this middle dot, how many boxes left or right did I go? Well, it looks like this was made up of a right movement overall plus an up movement. So I need to count how many boxes did it take to go right, and then how many boxes did it take to go left. All right, well, let me count. Well, I could go directly to the right, but the fire's in my way, so I'm going to actually break it down like this. My vector is made up of this set of two motions. Now, if I count how much did I go to the right over here, that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So I went 10 to the right, and because it's to the right, it's a positive 10. And then if I take how much up it went, counting boxes, I'm going to count this length here in terms of boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's another 10. And because he's going up, that's a positive movement in the y direction. So my first vector to get Mr. Robot from the first point to the middle dot would be the vector. The horizontal was 10 to the right and 10 up. So I didn't really need a coordinate plane to help me. I could just count boxes. Now take that vector and just use your previous knowledge. Can you find out how do you find magnitude again if I give you component form? Feel free to look back at your notes if you need to. And how do you find direction? That's a newer thing that we learned last time. How do you find the direction of that vector? But I'll put a little star next to direction because remember, it could be a little tricky. You have to remember, check your quadrant. For example, my vector that I have here, if I was actually to draw that vector, that would be in quadrant 1 because that's a positive 10 and a positive 10. That's quadrant 1. So my direction angle, when I do the formula for that, if you remember it, my answer should also be in quadrant 1. So you have to make sure that these quadrants match. And if they don't match, we had ways to figure out how to get to the real direction, whether we added 180 or we added 360. So see if you can figure that out. For the rest of this first obstacle, now you need to take a vector from the middle dot to your goal. And same idea, break that into the horizontals, how far left and right, and how far up and down. And then write that as a vector here in component form. Then find the magnitude of it using your formula, and then find your direction. But again, big star, be careful of your quadrant. Make sure he matches your quadrant. And that's basically what you're doing for all of these. If you look at, for example, number 2, here's your little robot. What's his name again? We can't go straight through here because otherwise he'll be pulverized by these rock crushers. So we need to find a way that he can get around it using vectors. But you have to stay inside the shaded region. You can't go outside the shaded region. So stay in there and break it up into however many vectors. Here they suggest maybe 2, and I think you can do it. The only thing they don't give you is they don't give you that middle dot. So you come up with a dot yourself. Where do you want the dot in the shaded region to get you to the goal that you need? Write down the vectors, find the magnitude of those two vectors, and then find the direction using your formula. watch your quadrant. And the last one are these metal destroying saws. Again, our little friendly robot, Mr. Whatever, needs to get from here all the way to the end, but he can't go through these saws or he'll be just destroyed. So can you find a way, staying in the shaded region, he can sort of go around those saws using vectors? And you can be as creative as you want, but they have to be straight line arrows, or you can maybe go around this way or something, whatever you like to do to get there. They give you spaces for up to 4 vectors. A lot of people can do it in 3. I've even seen a few people do it in 2. But feel free to use as many as you like, as long as you stay in the shaded region. And as you find each vector, using the component forms, find the magnitude of each vector, and find the direction of each vector, and check your quadrants. Good luck, folks. Have fun.